Okay, so dividing complex numbers, you have to remember that I is a square root. Okay, so I'll write that first. I is basically the square root of -1, so it's a square root. That means uh, we must rationalize denominators with square roots, right? So anytime you see a square root in the denominator, you must rationalize it. Um, so anytime you have I in the denominator, you have to fix it somehow. So that's what we're going to focus on here. So let's first look at if I want to simplify something like 2 divided by I. Well, to rationalize this, the easiest way to do it is to multiply both top and bottom by I. And what happens is, on top you get 2I, and on bottom you get I squared. Except that I squared is -1. So, by multiplying I times I, that gives us the I squared, which we can then replace with a -1, and there's no radical on the bottom. And 2I divided by -1 is -2I. Okay? So 2 divided by I is the same thing as -2 times I. What if I have 3 plus I over 2I? Well, again, in this case, to make this an I squared, I can multiply top and bottom by I. And on top, it would just distribute. So I'd have 3I plus I squared over 2I squared, right? And then all the I squareds I have to replace with -1. So I've got 3I plus -1, which is just -1, over 2 times -1, which is -2. Now, we like to write this in the form a plus bi. So I'm going to take the real part, which is -1, and put it over the -2 first. And then I'll put the imaginary part, the 3i, over the -2. And I can say plus 3i over -2. And so -1 over -2 is positive 1/2. A positive divided by a negative is a negative, so I get minus 3/2, and I'll put the I out to the side, and now this is in the form a plus bi. Now the plus or minus doesn't really matter, it just means that the second term is negative. So this is acceptable. Now what if you have two terms on the bottom, so something like 2 plus I divided by 3 minus I? You do not want to multiply top and bottom by I. The problem with that is if you distribute it, you're going to get a 3i here and an I squared here. Now the I squared is fine because it's going to become -1, but then 3 is going to become 3i, and you haven't gotten rid of your I, so you have to multiply by something else. Well, just like when we rationalized fractions with two-term denominators that have, with square roots, you would multiply by what we call the conjugate. So 3 minus I, if I multiply it by 3 plus I, it multiplies out very nicely to where all the i's disappear. So I have to multiply everything on top and everything on bottom. So 2 times 3 is 6. I times I is I squared. Then here I get 3i, and here I get 2i, so that's a 5i in the middle. On the bottom, 3 times 3 is 9. Negative I times positive I is negative I squared. In the middle part here, I get negative 3i, and on the outer part I get positive 3i, and they cancel. That's the key. When you multiply conjugates, the middle term cancels out. So what we end up with is I need to replace all my I squareds with -1. And so we have 6 plus this -1, that's 5, plus 5i, over 9 minus -1, which is 9 plus 1, which is 10. Now I need to split this into my real and imaginary pieces, so it's going to be 5/10 plus 5/10 I, right? Put each of the 5's over the 10 and the I out to the side, and then reduce your fractions. So that's how to divide a complex number by a complex number where there's two terms on the bottom. You multiply by the conjugate of the bottom. The conjugate is the same thing, but instead of the sign that's here, if this is a minus, this is a plus, or if this is a plus, this is a minus. And that allows us to cancel out the middle term.